Hi, welcome back. I want to start today's video with a question, and I want you to answer it as quickly as you can. Here it is. Two straight lines are drawn in a plane. You are told that the two lines are parallel to each other. How many points of intersection do the two lines have? Go ahead, answer it in your head. The answer, as I'm sure you know, is 0. Parallel lines never meet. They have no points of intersection. Now here's what I want you to notice. How much computation did that require? None. Not a single calculation. You didn't need a formula. You didn't need a pencil. You didn't need to solve for x. You simply needed to understand what parallel lines are and reason from that understanding to an immediate, confident answer. That question, almost exactly as I just posed it to you, has appeared on the SAT. And a significant number of students got it wrong. Not because they didn't know what parallel lines are, but because they saw a math question, reached instinctively for computation, got confused when there was nothing to compute, and either guessed or wasted precious minutes going in circles. That is the story of SAT math in a single example. And that is exactly what this video is about. In the next few minutes, I'm going to show you the one thing that the SAT math section is really testing, and I promise you, it's not what most students expect. I'm going to show you two examples, both representative of questions that appear on a real SAT, that will permanently change the way you look at every math question you encounter from this point forward. And I'm going to give you a single principle that you can apply immediately to every SAT math question at every level of difficulty. Let's get into it. Let me start with what most students believe about SAT math. Most students believe that SAT math is a test of mathematical knowledge and computational ability. They believe that if they know enough formulas, have practiced enough problem types, and can execute calculations accurately under time pressure, they will score well. And to a point, but only up to a point, that belief is not entirely wrong. As I discussed in my last video, the first 400 points or so on the SAT do broadly reward content knowledge and familiarity. If you don't know what a quadratic equation is, you're going to struggle with questions that involve quadratic equations. That's simply true. But here's what changes as you move into the higher score ranges. The SAT, very deliberately, very systematically, begins to design questions where the student who reaches for computation is actually at a disadvantage compared to the student who pauses to reason. Let me say that again because it's so important. At the higher levels, the student who reaches instinctively for computation is at a disadvantage. The SAT is not rewarding the fastest calculator in the room. It's rewarding the clearest thinker in the room. And those are very different things. So let me put that down on the whiteboard. Let me go back to the parallel lines question I opened with, because I want to unpack it more carefully. Here is how that question typically appears on the SAT. I'm going to put it down once again on the whiteboard. Line 1 is y is equal to 3x plus 7. Line 2 is y equals 3x minus 4. And the question is, how many points of intersection between lines 1 and 2. Now, a student who sees this question and reaches for computation will likely attempt to solve the two equations simultaneously. She'll set 3x plus 7 equal to 3x minus 4. She'll subtract 3x from both sides and she'll end up with 7 equals -4, which makes no sense at all. And now she's confused, she's lost time, and she's lost confidence. A student who is reasoning looks at this question completely differently. She looks at the two equations and notices immediately that both lines have a slope of 3. Same slope, different y-intercepts. And she knows from her understanding of what slope means geometrically that two lines with identical slopes are parallel, and parallel lines never intersect. The answer, therefore, is 0, found in seconds with complete confidence. No computation, pure reasoning. Now notice what the SAT was actually testing here. It wasn't testing whether you could solve simultaneous equations. It was testing whether you understood the geometric meaning of slope well enough to recognize parallel lines when you saw them expressed algebraically. That is a reasoning question dressed up to look like a computation question. And that disguise catches a very large number of students. So, remember this. Now let me give you a second example, and I want you to really feel what happens in your mind when you read it. Here it is. Take a moment, think about how you would approach this. Now, a student who reaches for computation does the following. She thinks the average of 5 numbers is 24, so their sum must be 5 times 24, which is 120. Then she thinks the average of 6 numbers is 24, so their sum must be 6 times 24, which is 144. Then she subtracts 144 minus 120 equals 24. So the sixth number is 24. That's her answer. That approach works. The answer is correct, but it took time, it required 2 multiplications and a subtraction, and it created opportunities for arithmetic error under pressure. Now let me show you how a reasoning student approaches the exact same question. She reads the problem and notices one thing and only one thing. The average did not change when the 6th number was added. And she asks herself, what does that mean? What kind of number, when added to a group, leaves the average completely unchanged? The answer is immediate and obvious once you ask the question clearly. If the average of a group is 24 and you add the number 24 to that group, the average stays exactly 24 because you've added a number that is precisely equal to the existing average. It neither pulls the average up nor pushes it down. So the 6th number must be 24. No multiplication, no subtraction, no calculation of any kind. Pure reasoning, pure logic, and the answer arrived at almost instantaneously. Now, I want you to sit with that for a moment, because what just happened in that example is not a trick. It's not a shortcut. It's a fundamentally different way of reading a mathematical question. The computation student asked, how do I calculate the answer? The reasoning student asked, what does this question actually mean? And that single difference in how the question was approached made all the difference in the world. So, understand what is being asked. Before you begin to compute. Very, very important. Now let me step back and tell you what these two examples have in common, because they share something very important. In both cases, the parallel lines question and the average question, the SAT presented a mathematical scenario and asked a question about it. And in both cases, the student who scored the point was not the student who computed most efficiently. It was the student who most clearly understood what the question was actually asking. That is the one thing the SAT math section is really testing. Not computation, not formula recall, not speed, mathematical comprehension. Can you read a question and understand precisely, completely, and quickly what it is really asking you to find? Can you see through the surface presentation of the problem to the underlying idea it is built on? Because once you see that underlying idea clearly, the path to the answer reveals itself almost effortlessly, and the computation, where it's needed at all, becomes almost trivial. This is what I mean when I say the SAT is a reasoning test disguised as a computation test. And this is why two students with identical content knowledge who have studied the same material, practiced the same problem types, and put in the same number of hours can score very differently on SAT math. One of them is computing, the other one is thinking. The SAT rewards the one who is thinking every single time. So let me bring this together. The one thing the SAT math section is really testing is your ability to understand what a question is asking, truly and completely, before you attempt to answer it. At the higher score levels, the students who pull ahead are not the ones who compute fastest. They are the ones who pause just for a moment to ask, what is this question really after? What idea is it built on? And what is the most direct, most elegant path to the answer? That habit, that pause, is worth more points on the SAT than any formula you could memorize. In my next video, I'm going to move to the reading and writing section, and I'm going to show you why even high scorers still struggle with SAT reading and what they're almost always missing. Because the same principle we discussed today, that the SAT is testing something deeper than the surface question suggests, applies just as powerfully there as it does in math. If you haven't already, please subscribe so you don't miss it. And I'd love to hear from you in the comments. When you're doing SAT math practice, do you find yourself reaching for computation instinctively? Or have you started to develop the habit of reasoning first? Tell me where you are with this. I read every single comment. I'm Narain, and I'll see you in the next video.